Today we are simplifying complex fractions, and the way that you simplify complex fractions is that you combine all terms in the numerator, combine all terms in the denominator. And so then what you have is a fraction that has one fraction in the numerator and one fraction in the denominator, nothing else. And at that point you divide using our rules for division, which is dividing by fractions is easy as pie. Flip.
The second and multiply.
Thank you. All right, flip the second and multiply. All right, so then we're going to make sure we include domain restrictions after we have written our final answer. All right, we are going to simplify this complex fraction. And I know what you guys are thinking. This looks like so much fun.
Yes.
Yes, it does. All right, so what we need to do is we need to combine the two terms in our numerator, the x over 2 and the 4, and combine the two terms in our denominator, the 5 and the 3 over x. And to do that, because we have a fraction in both the numerator and the denominator, we're going to have to find common denominators. So for the numerator, your common denominator is 2. And for the denominator, your common denominator is x. I'm going to find a common denominator so that I can combine the x and the 2 with 4. All right. So that is the numerator as we have it, but I need the 4 to have a denominator of 2. So I'm going to multiply by 2 over 2. And then this is the denominator as it was given to us. But in order for me to combine the 5 and the 3 over x, I need a common denominator. So I'm going to multiply by x over x. When I do that, I get x over 2 plus 8 over 2 over 5x over x plus 3 over x. And now what you can do is you can combine the two pieces of the numerator and the two pieces of the denominator. So that is x plus 8 over 2 all over 5x plus 3 over x. So I added the two pieces of the numerator to get that, and I added the two pieces of the denominator to get that. And now what you have is a fraction in your numerator and a fraction in your denominator. And so this is the division step, right? Because what I have is a fraction divided by a fraction, and so I do that division. And remember that dividing by fractions is easy as pie. You flip the bottom and multiply like that. And when we multiply, we get x times x plus 8 over 2 times 5x plus 3. Okay. That is our answer. That is our answer. And that looks a lot less scary or complicated than the problem we started with, because it's just a fraction at this point. Now, it is a rational expression, and I got to this rational expression by starting with rational expressions. So we need to deal with excluded values or domain restrictions. So we can't have a denominator that's equal to 0. So right here in my problem, this denominator cannot equal 0, right? How do I figure out where that denominator would be 0? What x value would make that denominator 0? And the way you do that is you just set it equal to 0. So the 2 is not a problem. It's just a 2. But I want to know, where would 5x plus 3 be 0? Yeah, we have to divide by 5, and we get x is equal to negative 3/5. If I plugged in negative 3/5 for x, that would make the denominator of this fraction 0. So I need to say that. I need to be like, hey, x can't be negative 3/5, right? We have to exclude that value because that value would make our denominator 0. Now, that's not the only value we need to exclude because we had fractions at the beginning of this problem as well. So we need to look back to the beginning of the problem at our denominators. Here, the denominator is 2. That is not an issue. 2 is never going to be 0. But this denominator, the one under the 3, that's an x. And so there, we also need to say x can't be 0. X can't be 0. And so that needs to come over here as well. So x cannot equal 0. And that is our answer to this problem. All of that together. All right, so we are going to simplify this complex fraction. And before we get started simplifying, we'll go ahead and exclude the values. We'll talk about domain restrictions because there are 3 fractions in this problem. I'm looking at the denominator up here in the numerator of the fraction, the x plus 5. We know because the denominator of that fraction is x plus 5 that x cannot be negative 5. So that I will have to carry to my answer at the end. So I'm identifying it here, and then I will write it at the end of the problem with my answer. Now, for the 2 over x minus 3 in the bottom of the fraction, x cannot be 3. And for the 1 over x plus 5, again, x cannot be negative 5. And again, those are our excluded values or our domain restrictions that we will carry to the final answer for our problem. All right, this problem is actually a little easier than the last one because I only have to combine terms in the denominator. The numerator is already simplified. It is 1 fraction, so I don't have to combine anything. But in the denominator, we do have to combine like terms. And so we need a common denominator. All right, so I'm going to ask you guys, do x minus 3 and x plus 5 have anything in common? They do not have anything in common. The answer is no, they don't. And so I don't have a common term to write down for these 2 denominators. I just have the pieces of the first denominator and the pieces of the second denominator. So the first denominator is x minus 3. And the second denominator is x plus 5. And my common denominator is just the 2 of those things together. All right. So this is 3 over x plus 5, and that's just a restatement of the numerator. And then here I have 2 over x minus 3. That's a 3. And I need to change that fraction so that it also has an x plus 5 in the denominator. So I multiply by x plus 5 over x plus 5. And then I add 1 over x plus 5. But I need to change this fraction so it also has an x minus 3 in the denominator. So I multiply by x minus 3 over x minus 3. Like that. So we get 3 over x plus 5 over 2 times x plus 5 over x minus 3 times x plus 5 plus x minus 3 over x minus 3 times x plus 5. Now, At this point, we need to be careful not to get excited about canceling out terms. I notice that there is an x plus 5 in the top of this fraction and also an x plus 5 in the bottom of the fraction. If I cancel those two out, we'll end up back at the step above this one. So don't cancel out those terms. What we're going to do is we're going to go ahead and add the terms in the denominator together. So I have 3 over x plus 5 over 2 times x plus 5 plus x minus 3 over x minus 3 times x plus 5. And I'm going to go ahead and combine the 2 times x plus 5 and the x minus 3 so that I have one group of terms in the numerator there. So this is 3 over x plus 5 over 2x plus 10 plus x minus 3. And that is 3x plus 7 over x minus 3 times x plus 5. And now for the part of this that we have all been waiting for, which is the division part, right? And how do we divide fractions? Dividing by fractions is easy as pie. I flip the bottom and multiply. Okay. And so when I do that, I notice that there is an x plus 5 here and an x plus 5 here, and that means I can cancel them out. So there goes the x plus 5 from the denominator, and there goes the one from the numerator. That's exciting, right? And so I've got 3 times x minus 3 over 3x plus 7. And that is our simplified rational expression. That's our simplified rational expression. We're done simplifying at that point. It is one fraction. So I took a rational expression composed of 3 fractions and made it into one. Now, I need to include my domain restrictions. So from the beginning, I know that x cannot be 3 and that x cannot be negative 5. But then I also need to consider the denominator at the end of my problem, which is 3x plus 7. So I need to say, where would 3x plus 7 be 0? And that's where x is negative 7/3. And so that is part of our excluded values as well. X cannot be negative 7/3. And that is your answer. All of it.